Lesson 17, the hyperbola part 2. Change of origin. The center of the hyperbola, this is the origin, that is 0, 0. If the center is changed to the point h, k, the new equation of the hyperbola in the standard form, or this form is expressed in this form with major axis horizontal. Considering the major axis horizontal, we have the vertices v1 to be h minus a, k, and v2 h plus a, k. The foci f1, you have h minus c, k, and f2 h plus c, k. Similarly, considering the major axis to be vertical, you have this form of the equation of the hyperbola with vertices v1 and v2 and foci f1 and f2. Examples number 22. Find the vertices and the foci of the hyperbola 16x square minus 3y square equal to 48. Solution: write the given parabola in this form. That is so because in the standard form, the right hand side is always 1. To achieve that, from here you divide through by 48 and you simplify. You have it in this form. Comparing with the standard form, you can see that a square is equal to 3. You have a square in this position, you have 3 in this position. This implies that a is equal to plus minus square root of 3. B square is equal to 16, which implies that b is equal to plus minus square root of 16. That is plus minus 4. Now, b square is equal to c square minus a square. To make c square stand alone, you transfer this term to the left hand side. You have it in this form. Therefore, c square is equal to 16 plus 3. That is 19. Therefore, c is equal to plus minus square root of 19. Hence, the vertices are v1. You have a, 0. A is root 3. That is plus root 3, 0. And the second vertex, v2, you have the negative a, that is minus root 3, 0. The foci are f1, that is c, 0. You have root 19, 0, and the second one is minus c, 0. That is minus root 19, comma 0. Example 23, write the equation of the hyperbola s square minus 9y square minus 4s minus 54y minus 86 equal to 0 in 8 canonical form, and hence find the foci and vertices. Solution: the required form is given by this equation. So we need to simplify the given hyperbola to give us a result like the required form. The terms that contain s and y, you bring them together and transfer the constant term to the right hand side. You group these two terms, you have it in this form. If you group these two terms, you can factor out minus 9. You have it in this form. You need to express the quadratic terms as perfect squares. To do that, from here, you take half the coefficient of s, that is minus 2. You square it, you have 4, you add it. When you come here, half of coefficient of y is 3, you square it, that is 9, you add it. In order to have a balanced equation, this 4 here, you come here and add it. Here is 9 times minus 9. You have minus 81. You add minus 81 also. If you factorize from here, you have these results. Factorize from here, you have this result. You simplify the right hand side, you have 9. To have the required form, divide through this result by 9. You have it in this form. From here, we can get the foci and vertices with ease. It follows that a square is equal to 9. This implies a is equal to plus minus square root of 9, and you have this result. B square is equal to 1. This implies b is equal to plus minus square root of 1. You have this result. C square is equal to b square plus a square. That is 9 plus 1 equal to 10. Therefore, C is equal to plus minus square root of 10. The foci are F1 with this information, that is H from the standard form. H is equal to 2 minus C, that is root 10, comma, then K is minus 3. F2 is equal to this information. You have it in this form. The vertices are V1 with this information. H minus A. A is 3. H is 2. So 2 minus 3 is minus 1, K is minus 3, and V2 with this information is equal to 5, minus 3. End of lesson 17. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live preciously and be prepared. Goodbye.